So thanks very much, Jim, Professor Herbsleb, for joining us today in our course on empirical software engineering. So Professor Herbsleb is a professor in the Institute for Software Research in the School of Computer Science at Carnegie Mellon University in Pittsburgh. And his research interests lie primarily in the intersection of software engineering, computer-supported collaborative work or cooperative work, and socio-technical systems, focusing on such areas as geographically distributed development teams and large-scale open source development. And Jim, you hold a PhD in psychology and a master's in computer science. And maybe you can explain that to us in a minute. And
Sure.
I just want to let the class know that Jim Herbsleb has won an amazing number of awards, like the ACM Outstanding Research Award, which that talk was related to that we watched today. I also posted your paper on that, and the Alan Newell Award and the Most Influential Paper Award and ACM Distinguished Paper Awards. Wow. And Best Paper Awards at CSCW. So we're really honored that you're here today. And in your bio, you share with us that you have also worked a lot in industry and that you've been a professor for the last few years. And I thought maybe if you just wanted to start off before we got into the questions, if you want to tell us a little bit about, how PhD in psychology, kind of how you use that and how you ended up working in industry. I think Bell Labs, right?
Yeah, God, it's a long, tortured path. So I won't go into too much detail, but my first trip to graduate school, I was in a joint degree program, actually. I got a PhD in psychology and a law degree, worked on those at the same time. I took the bar exam because I felt like if I went to law school, I just might as well finish it off and be a real lawyer. So I did pass the bar exam and become a lawyer. So then I taught psychology for a while at a liberal arts college, got really bored with that. Went back to graduate school, this time in computer science. I don't know why they accepted me. I'd never taken a class in computer science or written a program or anything. It was quite a weird experience. But anyhow, that was at University of Michigan. I was in a PhD program, but after I got my master's, I was offered a postdoc, which paid a lot better. It sounded like a lot more fun. So I just quit the program of the master's and went to work in a lab as a postdoc. Then I went to the Software Engineering Institute after a couple of years as postdoc here in Pittsburgh. Got hired by Bell Labs, Lucent Technologies, was there for 6 years until they collapsed in a big heap in the dot-com bubble. And then that was about 2002, I came to CMU and been here ever since.
I'm doing great work there too. So for today's class, we watched your keynote presentation at ICSE, which is a wonderful talk. And I think it did a really fantastic job of summarizing a lot of your work on socio-technical theories and socio-technical congruence. And the students have prepared some questions. So we're going to go through some of those. They're grouped sort of a little bit by theme, but we might jump around a little bit. So everybody watch Zoom chat to see who's up next. And so the first ones I thought we'd talk about is about a coordination and your findings on coordination. And I thought I'd invite Nimi to start asking a question.
Yeah, sure. If we take the research question, how varying the coordination techniques at the beginning, at the middle, and at the end of a software development project, you mentioned that this research question was not being studied by the time you presented the talk. Has this been studied by now? And if not, what is your hypothesis for this research question?
I don't think it's been studied directly. So if you think of, this is my weird way of thinking about things. If you think of a software engineering project as a bunch of decisions, technical or engineering decisions that have to be made, then you can imagine as you keep making decisions, this network of decisions and constraints evolves over time, right? There's only a certain number of decisions left, and it's only the constraints among those decisions that matter anymore at that point. So I think, the way it changes kind of depends on how you make decisions. If you modularize, which means you make a bunch of decisions that cut the problem up into a bunch of smaller problems, then it gets increasingly simpler and these decisions become more isolated from each other. But I think there's other things at work, which we've kind of seen, which is, and a lot of other people have seen as well, which is that there comes a point when a system's being developed, it's often developed kind of the basic modules are developed first. And so teams are only talking to themselves because they're just building a module. Then at some point when more intense integration starts, you put all these pieces together, each of which is perfect, you put them together and they don't work at all. But, it's the usual sort of thing. Then, there's a lot more cross-team coordination trying to resolve all these problems, across the whole system. So a nicely designed modularized system helps to isolate the work for a while, but then there's always a step where, the integration requires going across the whole product. So I think the coordination needs kind of change in that sort of a rhythm, more isolated than stretching across the whole thing. And then towards the end, it's just usually a bunch of bug fixing. Those are usually independent little actions that hopefully don't have a lot of implications. So it's a lot of isolated bits of work at that point. So my guess is that's kind of the rhythm. I don't know that anybody's looked at that, very formally or any greater detail. I think many people would share similar observations.
Yeah, super interesting question though, Nimi, to think about that kind of along the life cycle of a project.
Good question.
Yeah. Jory actually asked, and maybe I should even know the answer to this, but I don't, what research is there on finding optimal coordination techniques in terms of, I guess, the channels, meetings and email or, Slack, whatever it is we use today for Teams. Are you familiar with research on sort of optimal coordination techniques or even at a certain point in time?
I don't think we have anything that, that's a really great question, but I don't think we have anything that approaches that. I think Peggy's done kind of the outstanding research on the use of different communication channels, for example, and developers tend to use a lot of them. So we know that thanks to what Peggy and her students have done. But I don't think anyone's really paid much attention to figuring out how do you optimally coordinate a project. I think I'd love to see us get to the point where we can say, okay, here's the project we have. Here's what we know about it early on. And for this project, we should, this subset of people need to adopt a coordination tool right off the bat. They should have their own Slack channel and should coordinate it there. Other things are so hard to coordinate that we should only assign that to a bunch of people on the same corridor of the same building because they're going to have to talk to each other all the time. So we don't really know much about how do you compose all the different ways that we can coordinate into sort of a complete solution.
Mm-hmm.
That's a big unknown space and an important one. I'd love to see us tackle that more systematically.
Yeah, it's a really good question. Actually, it's something. Maybe we should look at in the future. And it's interesting though to think about, companies like Microsoft, right, where they use Teams, right? And so their communication tools are almost prescribed by them, right, by the environment they're in. But, do those work or not? We don't know, right? So yeah, thanks for that question, Jory. I'd like to invite Rohit to ask the next question. Pudari?
Yes. Yeah. So my question was, are there any existing systems which can usefully predict coordination requirements? If yes, how early in a project do you think the data is sufficient to predict those requirements?
Yeah, good question. So we did look, using the kind of matrix multiplication approach that I talked about in the talk. We looked, and we're looking at interconnections among files based on files being changed together. So you have to have some change history, right, before you can compute that. So one of the questions that one of my students, Marcella, looked at was how early in the life of a project does that matrix stabilize? And it turns out pretty early. It took a couple of months in the case that we looked at for that to become quite stable. It gets added to a bit, there's some connections that are made later, but it doesn't change much after that. So even using that technique, which is kind of after the fact, you could use that a couple of months in. We came up with other ideas we haven't had a chance to test yet about taking the early architectural design of a system and just qualitatively interviewing the architects about each of the connections among these components, and asking them questions like, between these two components, is there interaction? If so, is the interaction complex? If it's complex, it's going to take more coordination. But even worse is it uncertain? Do you really know how they're going to talk to each other at this point? Do you know what the messages are going to look like? Do you know if you need a high level and a low level interface? Or, do you have any idea what you need? Have you done something like this before or not? And if it's really uncertain, that's when you really, really need to make sure that you have a lot of capacity to coordinate. You probably want to assign those modules to people in the same location, for example. So we tried modeling, very rough coordination requirements, and then try to estimate the coordination capabilities of different teams based on their history of working together or not, and their geographic location, and so on. And the hope was that that would be something you could apply very early in system design.
Yeah, thanks. Thanks for that question, Rohit. That's super interesting. And actually, I'm going to go off my script here a little bit and jump to Sarush, because his question nicely follows on from this one. Sarush, can you jump in?
Yeah, sure. Hi. So my question was about the coordination requirement matrix. So using this, we can see like what two team members have shared code or like shared contribution in a common file. But doesn't this, like, how accurate is this? Doesn't this increase the number of unnecessary coordination, and like with end up having like a waste of time at some point? Because right now we're already struggling with number of meetings that groups tend to have, and they think of it as interruptions. I was wondering, like, what's your idea on that?
Yeah, no, great question. And actually, I think it's probably not a very good measure of coordination. I mean, so in my mind, several different pieces to this work. The theory is about thinking of coordination as a distributed constraint satisfaction problem. And as the act of coordinating is, you can think of that as a social algorithm by which the organization is trying to solve that distributed constraint satisfaction problem. So all the stuff about multiplying matrices and all that was just a methodological thing. We're just trying to figure out, how would you compare the technical and the social and see if they match and see what the consequences are. That was just one way of doing it. We never thought it was going to be a great measure, but we thought it was at least one way to approach the problem, right? To get these comparable matrices and compare them and look at outcomes based on the match. So yeah, I don't think it's a great, I don't think it's terribly accurate. I think if you were to try to use that as, something where you would sort of force people to talk to each other if they had something in the coordination requirements matrix, I think that's a bad idea. But so, it's just a step on the path. We need better and more refined tools if we're actually going to try to guide people's behavior. Although IBM actually built a tool that tried to do that. I think they eventually abandoned it, probably for exactly the reasons you're thinking.
Yeah. Okay, thank you.
Great. Thank you so much, Sarush. Shuja, we'll go back to talking a little bit more about the earlier questions about coordination. Shuja, would you like to jump in?
Yeah. Hi. Firstly, thank you so much for joining and coming to this session. My question is that in your opinion, to what extent is the success of application of the coordination technique depends on the individual who are involved? Also, should we be selecting the techniques based on who those individuals are, because their experiences varies, personality traits varies, and stuff like that?
Yeah, that is a terrific question. And I think the answer has to be yes, that the coordination techniques that are going to be successful depend on the individuals. We had some other work where we looked at communication networks in a commercial setting, which developers communicate with each other and how frequently, and you made a network looking at that. And what was interesting is we found that, you know, along with a lot of other research that points the same way, we found a few people who act as kind of communication hubs. They communicate with lots of people, and they tend to be the people who join different groups. They have different cliques of people who talk to each other, but these big hubs kind of span these groups and are able to spread communication broadly across the organization. Well, I think it's a certain kind of person who can do that, right? A certain kind of person who can manage many connections. And the thing that surprised me most about this was those people who managed most of the communication also did most of the technical work. These people are kind of amazing. You probably know that for a long time, we've known that productivity in software development varies dramatically from person to person. And what we found, to my surprise, actually, in these networks is that the people who tend to be hubs are also people who write most of the code. I think it was out of 114 people, 18 of them wrote half the code, and they were also the communication hubs. And so I think it's very dependent on being the right kind of person who is both social and technical, who can pull that off.
Thank you so much.
Thank you, Shuja. Thank you. Little bit of a change in topic and looking maybe a bit to the future of coordination tools. Derek, would you like to ask your question?
Yeah, so do you think that we'll see a feed sorting algorithm kind of onto GitHub, kind of like Facebook? You're saying how it's kind of social media-like, so will we see some of the tools, the algorithms have been huge, those move into the same space?
Yeah, that's a great question. I think there's been work, Gail Murphy, for example, computes degree of interest of different developers in various artifacts and attempts to reveal them to developers as needed based on what they're doing at the moment. And you could think of that as kind of very similar to a feed sorter, right? That tries to put the stuff in front of you that is most relevant to you. There's a bunch of ways of doing that. You know, her task top, for example, does that based on developer tasks. You can store a task with all its associated artifacts. She did some very early work in this area with Hippocat, which uses information retrieval approaches. So yeah, I think that work is kind of here. A lot of people are doing that, and the task top approach has been commercially extremely successful. So I think there's a future in doing it better and better. I think that's a great idea. Good question.
Yeah, and yeah, it's good to call out Gail's work on that. It's been really quite transformative, especially the stuff they did at TaskTop. And Andy Bagel, I think, also did some work in Codebook, which was kind of similar to Facebook. Richard, yeah, it's sort of following along the same lines of looking to the future of tools. Would you like to ask your question?
Yeah, so I was wondering if you thought the emergence of new tech like AR, VR would have a noticeable impact on coordination or coordination tools at all.
That is such a great question. I remember, so I looked over some of the questions in advance, and I came across that one and went, wow, gosh, that's such a good question. I hope they don't ask that one. No, it's a really good question. I don't know. I mean, the only thing that I've thought of at all is, being in the same location as other people is very convenient in a lot of ways, because, with a lot of interactions over time, you come to understand each other better. If you bump into somebody in the hallway, it's an occasion to possibly exchange information. You've probably had that happen to you, where you see someone in the hall, oh yeah, there's something I need to tell this person, or there's a question I need to ask. All these kinds of informal things that happen face to face, but not when teams are distributed. So the thought that I've had, many people have had actually, is could you use something like AR, VR to create a virtual environment? In fact, back in the days of Lucent, this is 20 years ago, we used to call it the virtual 30 meters, because it's findings that, the closer people's offices are, the more frequently they talk together. Once you get out 30 meters away, they might as well be on the other side of the earth in terms of how frequently you talk to them, which is kind of startling. But so we used to talk about, can we create the virtual 30 meters? so that all the people you need to be in close touch with are right there somehow. We didn't quite know how to do that. We had some chat-like tools and other things like that, which seemed to help. But maybe with AR, VR, you could actually almost physically realize that and have your team distributed around the world, but you all seem to be right there. That's the only way I can see of addressing that. But that's a really good question.
Yeah, I totally agree. And, you know, definitely some out there research on that, right? It's come up a little bit over the years, but, you know, now the Oculus and, you know, the Vive and so on, they're pretty awesome, actually. So I think
Really?
like we're there again, right? That we could look at that. And especially with remote work, it's a very fascinating, you know, thing to think about. Thank you, Richard, for bringing that up. Little change in direction here and thinking about communication and information flow. Matt, would you like to jump in?
Sure, thanks. So the theory that you introduced in your talk with the network of decisions, I can see how that can help to answer questions, you know, of who needs to communicate and how you can split up a project and that sort of thing. But I was more wondering about how you choose a communication tool, and I was wondering if there's a theory that takes into account the complexity of the coordination and the amount of information that has to be communicated and that sort of thing.
Yeah, that's a really good question. It's a tough bit of research to do. I mean, the best answer we came up with for that sort of a question comes from theory, not from us, but from so the organizational behavior world. So they talk about what are the sources of complexity? You know, why do you need to communicate with someone? If something's very complicated, but you know what it is, then something like documentation, very careful documentation seems like the answer, right? You just write it down. If you know, using the interface to this component is really complex, well, just document it, and then I'll read that and I can figure it out. The thing that's trickier, though, is uncertainty. If we don't know what, you know, we have our initial design ideas about what the interface is going to be, but we're not sure because we've never done this before or whatever. That's much more difficult to address, and that almost has to be some communication-based form of coordination, where you sort of work it out together. You know, you attack the uncertainty, you come up with mutually agreed solutions, you test them out, you may have to adjust them, and so on. So the best answer, and this is very abstract and not very precise at all, but is the nature of the difficulty. If it has more to do with uncertainty, then you're going to need communication-heavy tools. If it's more to do with complexity, then you just need to get the details down and get them right and record them and make them available. That's the biggest distinction that I know of to address that question.
Okay, thanks.
Great, thank you, Matt. Zane.
Okay, yeah, so you mentioned in the talk about waterfall, but for organizations nowadays, especially, you know, smaller organizations, they're often using DevOps or, you know, continuous integration, continuous development, that type of thing. So in your opinion, how has DevOps impacted coordination decision making? And if negative, what are some strategies to mitigate these negative effects?
Yeah, I think it's had a really positive effect overall, right? It means the software gets into deployment much faster, and the fact that it's in the kinds of contexts where DevOps is really successful is, you know, big online multi-host, you know, multi-cat, what do they call that? Multi-something, some multi-word I'm missing here. And there, you know, you can sort of separate out customers and do your testing basically on a small number of customers. And if it goes well, you can roll it out more and so on. So I think the coordination that's required for that is, you know, just tighter integration between development and operations and deployment. So, you know, the developers have to have a really good idea of when something is ready for deployment, and deployment needs to be able to move it quickly into deployment, and if problems occur, know when and how to back it out, and how, you know, who to get in touch with to sort of fix whatever problems they find. There's that, a lot of that kind of close coordination between the operations and the development, I think, is the new coordination issue that brings to the table. But companies have been solving it pretty successfully, and that, for a lot of companies these days, that's just the way to develop software.
Yeah, because in a Relay study, one of our findings was that DevOps and like continuous actually may hurt shared understanding within the company. And so
that's interesting.
Yeah, so that's actually something that was recently published. And I mean, it was with a few small companies, so that, you know, it may not necessarily generalize to large settings, but it was just something that we observed.
That's very cool. I mean, if you could send me the paper or put a link in the chat or something,
Sure.
That sounds interesting. I'd like to see that.
Sure.
Yeah, thanks, Zane. I was actually going to say, Zane, what do you think about your question? You already answered it. If you could put a link, put it in Coolridge, but also put it in the chat, Zoom, that would be super. Thank you so much. Great discussion. Alessandra, we've maybe touched on your question a little bit, but perhaps you want to dig into a part of your question?
Yeah, you have shared some opportunities and research questions regarding the technical and social aspects of the collaboration, such as the role of social media. And from that list and what we have talked today, which significant change or new challenges can be observed in the scope of collaboration? Or what you can highlight as a hot topic to be discussed?
Right. Well, I think one of the trends that we've seen, you know, ever since GitHub in 2007, 2008 till present, we're seeing a couple of things that really change the nature of coordination. I think one is that there's a vast set of libraries and frameworks. Some people are now calling it digital infrastructure that's just out there. And according to, I think it was the GitHub survey, 97% of companies make use of open source. So there's this common resource that's out there that companies participate in maintaining and building together. They kind of cooperate on those infrastructural kinds of things. And just the availability of libraries and frameworks out there to do all sorts of things means that you can develop stuff much faster, much cheaper than ever in the past, where you have to sort of start from scratch. So that's one thing. The other thing is the kind of environments that these pieces live in. I think of the major change as being transparency, where you can really see all the work that's happening. You can see not only the code, but you can see easily all the commits that have led up to that code. You can see what different people have worked on in the past. You can kind of see how many people have started something, you know, which gives you some indication, rough indication of quality. You can see how many people are using things now that GitHub has added that to their interface. So there's all sorts of information. It's kind of like any social media or recommender or you know, kind of social network where people's actions are made visible in ways that help other people find good stuff. So I think that's one of the major breakthroughs. And it also helps people who want to learn. You can kind of find, if you want to learn Java or something, find a great Java developer, which means someone with a few thousand followers, and then go back and study what they've done. And you can see not just the code they wrote, but you can see the commits. You can see how they broke the problem up, which pieces they did first, what they did later, and learn a great deal about, you know, how to be a good Java coder by doing that. So I think the openness of all the code really provides a lot of educational opportunities, as well as facilitating coordination by just observation.
Wow, thank you. Great question, Alessandra. I think you've maybe introduced another potential research topic for Alessandra, which she really doesn't need. She's so many things and she's such a, I consider writing fiercely. But yeah, great. That's a great insight. Thinking about, coordination by observation, like what observation leads to in that way is great. I think we're almost at the end. I'm going to invite Roshan maybe to ask the last student question.
Yeah, sure. So my big question is, now since teams have become much more dynamic and even companies encourage people to like move across projects, work in different areas. So has this made it much more difficult in estimating the communication constraints? And does the theory still hold in this scenario?
Yeah, I'd say so. My point of view would be, I think the theory still holds. I mean, I think still, any project is going to be a network of decisions and constraints. I think a lot of things do change though. So I was talking to someone, a European colleague who's done work on looking at congruence in open source, and finds that there really isn't any connection now between any meaningful outcomes and the congruence computed in the way we computed it. And that makes perfect sense to me, because people are not coordinating in the same way. They're not just coordinating in these communication channels. So congruence between the communication channel and the coordination requirements probably doesn't matter. People are just using the transparency of the environments to coordinate. So that dynamic aspect is also kind of interesting, with people being on more than one team and possibly changing teams frequently. It's good and it's bad. It's maybe bad in the short run because it's much easier to coordinate with people you've worked with before, and to coordinate about components that you've worked with before, because you understand it and can communicate much more easily. But on the other hand, in the longer run, it spreads the knowledge across more people, right? Which kind of improves your bus factor, if you want to get kind of morbid about it. You know the bus factor?
I don't think they do.
Well, it's I don't know. It's sort of the number of people who would have to be hit by a bus for your project to be in serious trouble. So if your bus factor is 1, you got one super genius who knows everything and nobody else can do the work, and they get hit by a bus, you're done, right? So in the kind of situation you're talking about, where people move around and work on different parts of the product, you get a much higher bus factor. So somebody, let's not talk about buses. If somebody leaves and goes to a different company or retires or whatever, you're not better positioned, because now you have a number of people who are familiar with that code and can probably take over and do that kind of work. So I think people in development organizations often don't think enough about spreading the knowledge around, to sort of reduce that kind of risk.
Great, thank you, Roshan.
Thank you.
Yeah, great question. We are unfortunately at the end of the time for your visit. Actually, we went over a little bit, but I was trying to sneak in another 1 or 2 questions. There were a lot of questions. You did, I know, look at them about after the pandemic, about, the opportunity it provides for studying teams and the changes that it might happen in coordination networks and so on. I don't know if you have any sort of closing remarks that you want to make about that kind of aspect, or anything else you would like to say as we come to the end.
Yeah, I think the pandemic has been a great research opportunity, as disastrous as it's been in terms of people's health, because all of a sudden, suddenly everything moved online. So we're working with Tata. Our department's moving into a new building, which is basically paid for mostly by Tata Consulting, TCS.
Mm-hmm.
They're putting a research group occupying a whole floor of our building.
Wow.
And they just went through a process of moving 300,000 developers from their older methods to agile methods. And then in the middle of this, of course, the pandemic hit, and now everybody's working from home. So we're hoping to get data from TCS and kind of study this working from home thing, which could never have been studied. No company would ever have done this, if they didn't absolutely have to. So we're trying to see what we can get in terms of data and support for that, and maybe we'll have some answers at some point.
Yeah, and there were some other questions we didn't ask about sort of changing from waterfall to agile and agile back to waterfall. But yeah, I guess you'll have this chance to kind of look at all of those things together as you study TATA or TCS. So thank you so much for joining us today, Jim, and taking time out on your Friday evening and letting us ask some questions about your great talk. And that's my dog joining in from the background. So yeah, I invite everybody to thank you for joining us today. And it's been great discussion.
Thank you all. Enjoyed the discussion. Great questions. Think about a research career. Follow your advisor's path here.
Yeah, actually we have some undergrads in the class and I'm like, you should do research. It's really fun.
It's great. It's more fun, you know, in terms of being able to be creative and follow your own path than anything else. All right. Thank you so much. Good to see you all.
Thank you so much. Thank you, Jim.